So in 2011, Lucia Tomljanovic and I wrote a paper on aluminum vaccines. It was our first, I guess you could say it, theoretical paper, epidemiological study. And we're not epidemiologists, we know that, but we actually had people who were that advised us. So basically, we were saying, the reason we did this is we had a little bit of time on our hands because we were waiting for animal care permits to be issued, and that takes a long time at UBC. You go through a series of revisions and modifications before you are allowed to do animal experiments. So we're waiting on that, and Lucia just joined the lab. She had written an amazing paper on aluminum and Alzheimer's disease. That's how I got to know her. And her paper came out in Journal of Alzheimer's Disease in 2010. So anyway, she joins the lab. We're trying to think of what we can do in the meanwhile because we don't have the animal care permits. And we say, well, let's just look and see if there's any correlation between how many times people get vaccinated with aluminum adjuvants and the changing rate of autism. Now, changing rate of autism is something you and I think is happening. Other people dispute whether it's changing or not. CDC seems to accept it, so, strange bedfellows. But anyway, there seems to be more belief that it's actually changing and it's not just better diagnosis and certainly not a genetic drift. So we simply look at two different data sets, one from the CDC, which is their vaccine schedule over the years, and how many of those vaccines were aluminum adjuvanted, and then we look at the changing rate based on, I guess, the U.S. Bureau of Census on the changing rates of autism. And there's a tight correlation. Now, correlation we recognize very clearly, as does everyone, that correlation is not causation. We get that. So then we took something called the Bradford-Hill criteria. And the Bradford-Hill criteria are meant to help you decide if the observation you have and the apparent correlation you have is actually plausible or if it's just random. And there are like nine of these criteria that have to be satisfied. And you don't have to satisfy all of them, but you want to have more of them than not. And we basically got hits on 8 out of 9. And so we felt pretty confident not to claim that aluminum adjuvants cause autism, but to say there's now a basis for more scientific studies. And that's precisely what we then did. So based on that, the idea that it wasn't completely a crazy idea, that there was something that had been satisfied by Bradford-Hill criteria, there seemed to be the possibility there could be not just a correlation, but actually a link to some sort of causal process. So then we started doing experiments. So we did the experiments with mice, we injected them with aluminum, and we saw various things. And that, we kept doing that. So we were following that thread, trying to understand if in fact at an experimental level we could duplicate some of the features of autism spectrum in animals with all the caveats and all the problems of animal models and all the things that you have to satisfy. And that's basically where we got to. And that's where we're still working. And we got to that point. We had started with behavioral stuff. We were working our way through the cellular changes, and we were then, the next logical step was to look at possible changes in genetic expression, and that's where that paper went off the rails because someone manipulated data in it. Not all the data, but some of it. And that led that to be retracted. So that work is being done again. We're doing another very, very large study, not using just the aluminum, but using the actual whole vaccines. And doing it's adequately powered. We actually have a statistician from UBC working with us closely to make sure we're doing everything in a way that should be beyond critique. At least he's going to stand by it. And we are going to be putting that out. And we presented some of these data in Lisbon at the Autoimmunity Congress, and we'll be putting out a paper on this soon. Again, it'll be a very long paper because it'll be ridiculously detailed about stats. Not everything changes, some things change. The aluminum group and the vaccine group seem to show some behavioral changes. We're going to document those. We're going to follow it up with a detailed histological analysis in the brains and the spinal cords. And then we have a short-term study. We're going to be looking at more biochemical markers to see what else is going on in short versus long time frames. So that's a kind of a normal process. You start off with an hypothesis, you check it against the existing literature, which is really all the 2011 paper was, which is still out there, and then you go do the experiments to test various aspects of the hypothesis. So that's been the whole process. People thought we just jumped in the middle. We didn't. We were following a very clear and established means of getting to a scientific answer. And that's what we continue to do. So nothing is different from the way
most laboratories go about dissecting scientific problems. You look at the big picture, then you zero in on experiments you're going to do, and you do the experiments, and you try and tie it back to the big picture. So we're in that process.